This. All right, so we are going to spend some time in class reviewing and just going over some proofs, spending the time looking at the proofs. Now, all of these proofs are going to use side, or angle, or corresponding parts of congruent triangles are congruent. When do you use that part? Do you remember? When did we talk about yesterday that you use this? It's after. At the end, right? It's after you've proved a triangle congruent. So this one is helpful for after, whoops, I moved my thing, okay. So after you prove triangles congruent is when you want to use that one, because then you can prove other things congruent. All right, so let's start with number one. We're going to write a proof. So we're going to have statements and reasons. Okay, we know AB. So we're going to do our given. So AB is congruent to CD. Okay, and that's marked, right, with these marks here. And we know that AB is parallel to CD. And that's marked by the little arrows. Okay, and so our reason is given. Okay, what else do we know? Not nothing. What would say that again? You said AB is parallel to DC? Is AD parallel to BC? I don't know if AD is parallel to BC. That's a good question. How do we prove lines parallel? Like if we look at some of the theorems for that, how do we prove them parallel? Okay, if you get out your the extra book over there, like this is your theorems and the theorems and postulate is there, because I'm going to have mine up here with me today. So if we look at the postulates we've had about proving lines parallel, have we had anything about that? We have the transitivity property of parallel lines. If two lines are parallel to the same line, then they're parallel to each other, but that doesn't help us. Wait, hold on. And we haven't got there yet. Yes, we have. We're in chapter 4. Yes, we have. 619 is the page to find the postulates and theorems. So that's the only thing. So I don't know about proving those lines parallel. That's not something we've done.
Well, what about the line just cutting through it?
Okay, the line cutting through it, that transversal? Yeah, what about it? So I'm going to extend this on out. Maybe that'll help us.
Since they're parallel lines,
Mm-hmm.
the angles on the transversal are congruent.
Okay. What kind of angles? So we've got a parallel line. This is a transversal. We know that there's angle relationships that are congruent. So what angles that are congruent would be helpful?
Angle ABD and angle.
So angle ABD would be congruent to angle. So one thing that I do, maybe I should show you this, is when I'm looking at these, I will go ahead and write the name. So A goes with C, so I'll write C up here, right? Because A goes with C. B goes with D, so I would write D here, and then D goes with B, and I would write B here. And over here I would write A. So when I'm naming them, so when I say like angle, A, B, D is congruent to, I would go to this A and say, oh, C, D, B. Does that make sense? For you all, like I write it so like it already takes it, because I would have to take this triangle that's here, this green triangle, I would have to take it and rotate it to make it match up. So I'm naming the angles correctly. So I would just do that to help me see those connections. And sorry, I have to draw the picture so when you're watching it, you understand. Okay, so those angles would be congruent. Why? What's the relationship? Did you guys agree that those are alternate interior? Are they on alternate sides of the parallel line? One's on top, one's on bottom. Okay. Are they interior to the parallel lines? Right? The parallel line is here, and right here, they're inside. So yes. So perfect. Step 2 would be angle ABD is congruent to angle CDB because they are alternate interior angles. Perfect. All right. So I'm going to erase some distractions here. Okay, our transversal and stuff. And I'm just going to mark those angles congruent. Okay. So right at this point, we have a side that's congruent. Right here, we have sides that are congruent, and we have an angle that's congruent. So I'm just going to I have a side and an angle. So I either need another angle to have that included, or I need a side.
You could do angle BA or angle GAB and then angle BCA.
Angle DAB.
Yeah.
You think DAB is corresponding to this one?
Yep.
But they're not, because they're not part of the transversal. Right? Corresponding has to be on the transverse. Oh, on the transversal. We can't prove them. They are corresponding, but we're trying to prove it. So does that make sense? Like they are corresponding angles, but because they're not on the same transversal and we don't know if they're congruent, we can't prove that they're congruent.
The middle line's congruent because it's the same line.
Yeah, this middle line right here. It is congruent because it's the same line. Right? It's side, it's the same side, right? It's a side for the triangle ABC, but it's also a side for triangle CDB. And so, yeah, but they're the same line. So we could say side BD is congruent to, again, look at it, BD is congruent to, not BD, look at how it's named. Oh, sorry, you might have said DB, I'm sorry if you did. Is congruent to DB because it's about the naming. Those are congruent, and what's the reason for congruence? Not step 3, step 4, it should be step 3 there. What's the reason for congruence here? Reflexive? You guys agree with reflexive? On your quick reference sheet, we've got reflexive, symmetric, transitive, reflexive? Probably symmetric. Good. We go with symmetric there. All right. So we just proved another side, right? So we've got a side congruent, an angle that's included, and the other side. So what do we know? Side angle side. Okay, side angle side proves what? Yeah. Yeah, so we can say triangle ABD is congruent to triangle CDB because of side angle side. We proved a side congruent, an angle that's included, it's in the middle, and then we got the other side. Because remember, again, that's the thing too, is they have to touch. So we got a side, the angle in between, and the other side. And we proved it congruent to a side, an angle in between, and a side. Because they have to touch. Very nice job. Was it as terrible as you thought it was going to be?
No,
Okay, well, let's look at number 2. All right. You don't know how to find the alternate interior angle stuff? Okay. So if we have these lines are parallel, we'll say. Okay. All right. And we have a transversal. So alternate means they're on opposite sides. Okay, so they're going to be one's on the left, one's on the right. So anytime it has alternate. So then we have alternate interior, which means they are interior to the parallel lines. So if this is my parallel line and this is my parallel line, they have to be somewhere in between that space to be alternate interior. Okay, they're inside the parallel lines. Whereas exterior are outside. So the alternate exterior, they still alternate sides, but they're on the outside of the parallel lines. So these would be alternate exterior as well. There's 2 sets. Does that make sense? Okay. Then we have corresponding. Do you understand corresponding? Was that yes or no? Yes? Okay. Because they're just in the same location. Okay, so this one's on top of the parallel line on the left, and this one's on top and on the left. Because if we took it and cut this and moved this one up, they'd sit in the exact same place and line them up. Okay, good. So it's just the alternate interior and exterior that was the struggle? Perfect. All right, so then let's go on to the next one. We'll clear some of that up. All right, so number 2, write a proof. We've got WV. So let me see here. Let's do statements and reasons again. We know that WV is parallel to X, or ZX, pardon me. So WV, it's got 2 little marks on it, is parallel to ZX. Okay, so these are matching up, right? W goes with Z, so I wouldn't relabel those. I would just leave them. We also know XW is parallel to YZ. So it's got the 1 little arrow mark on it to show that. And we know X is the midpoint of VY.
So this was like number 19 we did yesterday?
Quite likely. Because anytime we have midpoint, we know a lot of information from a midpoint. Okay, so if we know that X is the midpoint, right? What do we know about that? What's that tell us? Luke, go ahead. What is the definition of a midpoint? It's exactly in the middle. So what does that mean about this? It's exactly in the middle of VY. So what does that mean? If this is X is exactly in the middle. Okay, so we V dash X dash Y, that means that X is between them. But what does it mean when this is the middle? Like the exact middle. What does it mean about the relationship here and the relationship here? Yes, you do. When you get a Snickers candy bar and you cut it in half, what do you know about the 2 halves? They're equal. Like if something is in the middle, if you cut it in the middle, the 2 halves are equal. So what do you know about VX and XY? They're equal. They're the same. So they are congruent. That is what we can say. Okay, so we can say that VX is congruent to XY because of the definition of a midpoint. Because if X is in the middle, well, the 2 segments that it creates It just took one long segment, cut it in the middle. We have two equal halves, two congruent segments. Okay. So we're kind of done with the midpoint, right? Like that's kind of all we can do with the midpoint. Is knowing the definition of a midpoint and applying that. We got a lot of parallel lines here. Doggone it, I meant to erase. I was like, there it goes. Slowly but surely. Okay, so if we take, like our parallel lines are important. So let's take, and we remember we talked about we can draw an auxiliary line to help us see that. So let's draw an auxiliary line for this set of parallel lines, right? So we could see it maybe better. And our transversal. And then like, okay, now I've got two sets of I've got a set of parallel lines and a transversal. Maybe I can see something with my angle relationships that's going to help me. Let me move my pen out. Corresponding angles, absolutely. Yeah, we could use those. What corresponding angles though would you?
Corresponding angle V.
Angle V, okay.
The X.
So angle.
The bottom X, so V, or so Y, X, W.
YXW, okay. Are those corresponding?
No, Y, X, Z, sorry.
YXZ, okay, you're good. So are these corresponding?
Yeah.
Yeah, because they're on the same side of the transversal. They're both on this side of the transversal. And they're both on the bottom of the parallel line. So what do we know about corresponding angles?
They're corresponding.
Help them out. Congruent. Corresponding angles are congruent. So angle V is congruent to angle YXZ. Right? Angle V is congruent to angle YXZ. Good. And we said this was corresponding. We know this. Let's look up the theorem. What is the name of the theorem? The corresponding angle postulate? Okay, because I was like, we could do a couple things. So corresponding angles postulate. Okay. If you wrote, corresponding angles are congruent, I would take that too. Okay, like you're telling me what you know, that corresponding angles are congruent. So sweet. So we've got a side. We have an included angle. It could be. Side angle side. Is there? Do you know of any?
We can use angle side angle because they congruent corresponding angle. There's two corresponding angles.
What other one do you see?
VXW.
He says VXW. Okay, so let's really change my color here. VXW and angle Y. Are those correspond?
Yes.
To what? Not according to this, they're not.
No, because that one's on a line.
That one's on a different line. We don't know that that line is parallel to the two black lines.
Look, she drew the. That's why she went longer with the lines, so you could see that those ones are parallel, but then that one's not parallel with it.
Okay. Okay. You're good.
These two lines are parallel, and that's what they're on.
Okay. See, but you're taking it to the other set. We hadn't gone there. So he said this line is parallel to this line.
I was so correct, and you were trying to correct my correctness.
Which is true. Okay, so then angle Y, in this case, corresponds to angle VXW there. And so that's also corresponding angles are congruent. All right, so step 4, angle Y is congruent. Hold on, I need to put two little marks here. Oh, angle Y is congruent to angle VXW. And that is also because corresponding angles are congruent, or the corresponding angles postulate. So we got a lot of marks, right? Uh-huh. But now we have angle side angle. We don't have to do it in that form, like in that order, right? We proved, or we had that we proved that the side was congruent first. And then we proved an angle, and then we proved an angle, but it's the location of those that's important. So I'm going to clear all the extra markings. Okay, so we can, and sometimes that's helpful. If I do this again, maybe I'll give you 2 diagrams so you can mark on one and then have the other one as a clean copy. So we proved that these sides were congruent. We proved that these angles were congruent, and we proved that these angles are congruent. So we have an angle, an included side, and an angle. So what have we just done? Angle side angle that so what have we just done? What have we proved? What have we? What are we trying to prove?
Oh, B.
So we proved that
X is congruent to X, Y.
So you just proved it. Pretty awesome. You guys are getting good at this. Caden, you can't talk anymore though.
Why?
I won't do the next one.
Because he keeps talking and nobody else is getting a chance to talk and answer. Okay, because it's like looking for that treasure map. All right. Oh, there was somebody else. Let's look at, everybody got that down? Okay. All right, because we're looking for relationships. So it's okay for it not to come quickly or easily, but for us to take the time to look at it. All right. So let's look at this one. I'm going to set up my statements and my reasons. Might need to make this longer. All right, so first one, we're given IJ is congruent to LJ. Is that what that says? It's hard to read it on the board. IJ is congruent to LJ. All right, so I'm going to mark that. And HJ is congruent to KJ. So HJ, I'm going to put 2 marks, is congruent to KJ. Yep. Oh, sweet. Okay, so this one is given. All that stuff is given. And we want to prove that IH is congruent to LK. Right? So we want to prove that this side is congruent to this side. Okay. I don't know about you, but well, how would we prove it though? How would we prove that IH is congruent to KL? Because that's what our goal is, but how are we going to prove that?
I can just find the corresponding angle.
Because I mean, we don't have any parallel lines. We don't have a midpoint, but even if we had a midpoint, it would have to be J. Do what?
I thought J was the midpoint.
Well, J is the midpoint, right? So to say, but it didn't tell us anything. So we've already used I mean, we could write J as the midpoint because we know the definition, but that wouldn't help us with anything. How on earth, like these are 2 random sides. Unless I prove that the triangles are congruent, and then I use corresponding parts of congruent triangles to prove that those segments are congruent. So then the question becomes, can you prove the triangles are congruent in some way? What do you already have congruent? What parts of the huh? IJ, what is that? What part of the triangle is that?
I can't see it up there.
Okay, but is it a side or an angle? A side. So you have one side that's congruent.
And you have the other side.
You have another. So you have two sides that are congruent.
So would the J, both parts of J be?
Would both parts of J?
Cause like you make the angles for the J.
Could I make the angles? Could I? You mean like for the IJH?
Yeah.
Okay, so could I make this angle and this angle?
Yeah.
Could you prove that those are congruent? I'm going to erase our goal here for the time. Can we prove that those are congruent? That's a good question, because then it would be side included angle side. Oh man, that'd be awesome.
But it doesn't.
Can we prove that those are congruent?
Yes.
Caden says yes. Don't tell us why.
I know.
What is their relationship to each other? What kind of angles are those? Corresponding means we have to have parallel, but like go through the list. Are they corresponding? I don't have parallel lines. Nope. Are they alternate interior? I don't have parallel lines. Nope. Are they alternate exterior? No parallel lines. Consecutive interior. I still don't have parallel lines. We had remote exterior angles. Are these remote? Or yeah, remote exterior. No. Are they? Or no, remote interior angles is what we had. No, they're not. Right? Because that was like when we had a shape and like that line, sorry, went on or something. So we don't have that. Vertical angles. I heard no, and then I heard are they? We don't know. Are they vertical angles? Lucas is looking something up. Look up a vertical angle. If you're a little bit thinking, maybe look it up. You're probably gonna have to use your definition.
It's in there. It's in that packet that we.
Oh, that's right. There is a okay. Thank you. There is a packet. Look for reals. I keep telling you all to highlight some of the things in here. I need to do it myself.
What was that called again?
Vertical angle. There's a
Yeah.
what? Yeah, what? Well, that says, what does that say? That's a vertical angle
Vertical angles.
theorem, which is vertical angles are congruent. But what is a vertical angle? That's the thing. If you don't know what a vertical angle is, then we can't prove the theorem, if that's true or not. So let's go to the glossary, which I passed somewhere in the back of the book. Right, like definitions, glossary, whatever. We can find, if I can find either one. I know it's here. So if you know the definitions, you don't have to use the glossary, but we're thinking through them. So a vertical angle is a pair of non-adjacent angles formed by two intersecting lines. So are these lines intersecting? Yes, they intersect. Are the angles that we're talking about non-adjacent? Adjacent means they're side by side. So these are not side by side. Is that accurate? Then these are vertical angles. So absolutely, they are vertical angles. So what can we say about them? Well, that's the reason we know vertical angles, the vertical angle theorem, right? Says vertical angles. I don't know why my board is just quit working on me. Okay. So the vertical angle theorem says that vertical angles are congruent. So what can we say? Not angle I. I's up there. We got to give it a whole name. We want this angle down here. So IJH is congruent, yes, to angle. No, I. Okay, so angle's on this line. So we have to do L. Yes, to angle LJK. Woohoo! So what did you just do? In taking that step, you now have a side, an included angle, and another side that you have are congruent. So what did you just, what statement can you make now? Okay, what statement can you make? You're right, you've got side, angle, side. That means that triangle, you, sweet, judging. You just proved the triangles are congruent. Awesome. So now we can take that one more step and get what we want to prove. Now that we know they're congruent, we've done this, then we can use the corresponding parts of congruent triangles are congruent. So what are we going to say?
Yeah, I don't know. This is the hardest one.
This is the hardest one. Okay, but we just proved that the whole triangle is congruent. We said, hey, check it out. This triangle IGH, is congruent to triangle LJK. I think I said G earlier, which means not only are these things congruent, but yeah, but those are also congruent because we just proved the triangle is congruent. Yes, so we can say IH is congruent to LK because corresponding parts, because those are corresponding, of congruent triangles, because we proved that they're congruent, are congruent. So these corresponding parts are congruent because they're congruent triangles. So in order to use the CPCTC, we have to prove they're congruent first. And then we could make all kinds of statements. We could say, if we wanted to prove angle H is congruent to angle what? K.
I keep hitting at the switch on.
Well, it also helps. Like angle H is between the one that has 2 and 3 marks, right? So the angle that has between 2 and 3 is K. Like you can use those markings if you're marking. We could say we could have made this claim if that's what we needed to prove. We could have done any of those because we proved it congruent. So now we can say all the things.
Do we have to do the rest?
Dun, 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 dun. What do you mean? Do we have to do the rest?
For homework.
It's almost time to go.
What time do we get out?
11:30.
35, right? We can do one more in 5 minutes, can't we?
I don't know. Can you get it? It's done in like 30 seconds.
Okay, let's look at this one.
5 or 4?
Oh, I'm sorry. Yeah, number 4. Let's see if we can do it in 5 minutes. I think we can do it in 5 minutes. All right, statements, reasons. Okay, so PT bisects. Ooh, that's a good word. We're going to need that angle STQ and angle SPQ. One is given. What does bisects mean?
The angles are equal.
The angles are equal, right? It bisects the angles. So, STQ and SPQ. So we've got these two angles are equal, and it bisects these two angles. Sweet.
Hey, can I tell you something?
Yes?
The middle line's congruent.
Yeah, it is. I like it. He said the middle line's congruent. Okay, so let's say this. So we've got angle SPT is congruent to angle QPT. And we're going to put two of these. Like, because it bisects, we're going to put both of them together. So we just did SPT. So now we're going to say, how about we say angle STP is congruent to angle QTP. Nice. And that was because of what?
Bisectors.
Angle. What is it? Angle.
Bisector theorem.
Angle bisector theorem. Yes. Okay. Well, it also said, well, that's not the angle bisector theorem. Actually, the angle bisector theorem says if YT bisects, then it's half of whatever. Congruent angle bisector says if two congruent angles are bisected, then the four resultant. Okay, that's not it either. Wait, hold on. Okay. I think it's just the definition of angle bisector. That would be accurate. Okay. But sometimes we got to check. We got to pull up our references. Then, man, Caden told us another one. What is it?
The middle line.
PT. Okay, so line PT is congruent to. Oh, but look at the way they're named. PT lines up with PT this time. So yeah, PT is congruent to PT instead of TP. We don't have to flip them because we look at. I don't know why. I'm sorry that I always. Ah, that is reflexive. Because it's what?
Because they're not switched around.
Yeah, this is the reflexive property because they're not flipped around. A is equal to A or PT is equal to PT. It's when we flip them that we say symmetric.
And then we can do.
Nice. So now we just proved these lines congruent. So we've got angle, right? An angle with a side included and another angle. What statement can we make, Lucas? Oh, we got 2 minutes. We're going to make it.
Take your time with this.
We've got an angle, and a side, and an angle that are all three congruent. That means we just proved what? The two triangles. Yeah, the entire thing, the two triangles. So because we have an angle and a side and an angle congruent, we proved that triangle SPT is congruent to triangle QPT. Absolutely.
I think being able to go back and like look what the SAS
Yeah, All right, so I'm going to stop us here. The last two are not your homework. I actually have 2 worksheets for you to do, but they are not proofs. They have no proofs. Okay, so but